So, hi everyone. Thank you for coming to this session. I'm Steve, engineering manager at Parity, and I'm here with Hector, Polkadot application engineer. And we work for a team that's called Delivery Services at Parity. And at Delivery Services, what we do is that we are a bunch of engineers. So we love technology, we love Polkadot, we love Substrate, and we do our best to keep up with all the crazy and exciting capabilities that the core engineering team is building. And then we advise teams and projects in the ecosystem on how to build for Polkadot. So today we're going to share some of our learning and some of our explorations in this wonderful world with you. So what is Trappist? Trappist basically is a style of beer coming from Belgium that is typically brewed by monks in monasteries in a very, let's say, traditional manner. And they exhibit a lot of craftsmanship. And basically, this is also the name of a project that I started internally at Parity that I needed to learn and keep up with all the interesting capabilities that were being built in Substrate and Polkadot. And so I started this little pet project of mine, and then more people started to contribute to the project. And we are now using this as a playground, a developer playground, where we try some crazy ideas, where we integrate all the latest building blocks from Polkadot. Basically, we are also building high-level use cases that we then can share with the community. And so this is what we're going to do today. I gave a first presentation about Trappist and some very nice XCM demo at Decoded, where I went over like the basic type of flows that you have in XCM, like asset teleports, reserve transfer, and other things. And now this is basically the second session that we will do with Trappist, but with some more advanced use case and even some very exciting stuff that is not yet live on either Kusama or Polkadot. So a little quick recap about Polkadot. What you have in Polkadot, you have the relay chain that's providing the shared security for the parachains and basically the entire network. You have the parachains, which are custom-made blockchains for very specific purposes. And they are typically built with our technology called Substrate. You have XCM. XCM is a very interesting piece of technology. It's a language that allows you to send messages between the various parachains and to basically also enable application on top of those chains to combine capabilities from multiple chains. So this is a very exciting piece of work by the core engineering team. And every time I talk about it, and we talk about it with Hector, we have all kind of crazy ideas, and that's basically what we are doing with Trappist, is to actually experimenting with them. Substrate, you've heard about our framework to build blockchains. And Substrate, in the runtime of the chain, you have pallets, which are composable modules that you can use. Some of them we have are reusable. We have a library called Frame, and you can obviously also build your own modules, your own pallets. So I mentioned XCM. XCM is very exciting because it enables a whole lot of use cases and cross-chain application and services. And so we've taken a little screenshot of the website about Polkadot and XCM. And in this presentation, actually Hector will showcase some of those things that XCM enable, namely cross-chain token and NFT transfer. So in my first presentation at Decoded, I showed how you could transfer some fungible assets between different chains. Very excitingly, today Hector will show you the same but for NFTs. We also show reserve-backed asset, where basically some assets, some derived asset on a chain are fully backed by an underlying asset on another chain that's served as a reserve. Obviously, it enables multi-chain smart contracts, dapps, and DeFi building blocks, DeFi primitives. What we will also show briefly is a use case where fees can be paid using an arbitrary asset, so not the native token of the chain, but an asset that was configured to be called sufficient, which means you are able to just hold that asset and pay for fees with it. So without further ado, I will leave the floor to Hector, and he will share with you the very exciting use case we've been working on for the past month.
Okay, thank you. Okay. All right. So thank you, Steve, for the introduction. Before I start, I want to thank the whole delivery services team for contributing on this presentation. Also, the core team at Parity that helped us to analyze some of these new things that we are going to try. And first of all, I would like to start with the motivation of this presentation. What is the goal? Okay. Sometimes, like in some other presentations, we present the technologies in an abstract way. Okay, and then we say what we can build. Now we are going to do the other way around. We are going, okay, to present a use case, and we are basically saying which tools we use and we picked in order to basically make this use case to happen. Something that I want to do like kind of a disclaimer is like the use case will not be simple, right? So maybe you might feel a little bit confused at some point. But that's OK. And at some certain point, we as cross-chain developers, we need to embrace that complexity because now, like, the solutions are not just happening in only one chain. Okay? It's basically happening in multi-locations, in different locations, with different applications. And we will need to make our mind model, right, into this. Before I start, I want to say, like, this is not production. So please don't pick the code and put it on your production code base, OK? Because as we said, we are going to use some technologies we are not like ready or shipped yet into the Polkadot production code base. Also, this is a exploratory purpose. The use case we are going to show maybe like some kind of game theory or economic stuff. All right. Yeah, the idea here is to do a showcase, not to present a real application or proposal, right? The whole motivation of this is to inspire you to think like new use cases and to show like Polkadot has so much powerful that you can build the next generation of use cases with this. So what we are going to do? We are going to create a real-world assets application. So you might say, what is a real-world asset? A real-world assets are tangible assets or financial primitives with the potential to serve as a collateral in the DeFi industry. OK, good. So what is that about? Let's suppose that we got an off-chain asset like a property, all right? And you have a contract for that property. Maybe something that you can do with a real-world asset application is you can get that contract, which is going in a way to assure that in the future you will have like a certain fixed income. You can get that contract, and you can mint it into a real-world asset application, and then you will have, as a result, an on-chain representation of that contract or that real-world asset, okay, off-chain, and you get it now on-chain. And of course, that if you think about it, the format that makes more sense for this kind of representations are the NFTs. But there is a difference, right? These NFTs has an economic value attached. The NFTs means non-fungible tokens, but this one in particular has some economic value attached because it comes from the off-chain world that has some economic value. So the interesting part of this is like you can use that NFT through like this kind of application that we will explain a little bit now, and you can get as a result like fungible tokens like, I don't know, Grab BTC, DOT, Grab Ether, or a stablecoin. We will use a stablecoin. So we built an application which basically is an NFT borrow and lending application. So how this works a little bit. So the user will get this real-world asset NFT. It will be deposited as a collateral in this application. And that will basically provide some liquidity that then you can use, okay, to do whatever, or invest it on a different parachain, and this is what we are going to present now. Of course, that this kind of application will charge you with a fee, okay, but we will not include that in this use case because it's just a showcase. So, but we say like this is a cross-chain application, right? Because it's on the title of the presentation. So once we get the stablecoins borrowed from this NFT borrow and lending, what we want to do is transfer it to another location and use that money, okay? So now we are start thinking of different locations, like in comparison with what we had some years ago, where everything happened only in one chain, okay? So this is like the important stuff. Let's start speaking about what we are going to use for this use case. We'll use 3 parachains, all right? The first one is a Staymine, that for the ones that you don't know, is a common good parachain that will work as a reserve, okay? What this means is like you can get like any fungible or not fungible tokens like an stablecoin or an NFT, and this will work as the reserve, right? So what this happens is like you will have different, okay, you will make these assets to flow in the different parachains, but this reserve chain, sorry, will work as the source of truth for the assets, okay? Then we are going to have a stout parachain, which is a multi-purpose parachain, which will host this borrow and lending, this NFT borrow and lending application that will give us that liquidity or that stable coins that we can use after in other places. And that other place is Trappist. It's another parachain that will work as a DeFi hub parachain, okay? So we have the reserve, we have the application that basically locks the NFT and gives us liquidity, and then we have Trappist, which is like our DeFi hub that we will use to get some yields. So let's go to the sequence of what we are going to do. First of all, we will have the asset ID 1, which is the STUSDs. That's the stablecoin that we are going to use in this use case. Then the real-world asset that we were talking about is going to be the item ID 77. Okay, that's the NFT ID that we will use in this presentation. So first, as the assets were minted on Staymine, the reserve chain, okay, what we need to do is to basically send it to the 2 parachains. So we found the protocols, the NFT borrow and lending application, and also like the decentralized exchange that we will define on Trappist. For the ones that you don't know, there is this like DeFi stuff that happened or start happening in 2018, 19, something like that, right? Which basically some of the services that were offered as part of the DeFi hub stuff is the DEX, right? The centralized exchange. This basically lets like the users to exchange assets in a decentralized way, and that's what we basically built on Trappist. So we are going to reserve-based transfer the STUSDs from the reserve chain into the 2 parachains, okay? And for the ones that are not very much involved in this, how the cross-chain, thing worked, it's like when you are like reserve-based transferring assets, what is happening is like you are locking it on Staymine, on the reserve, and you are minting derived versions of STUSDs on the parachain that you are sending those. So you are, in a way, locking it, okay, on the origin, which is in this case a Staymine, and then you will create representations of that asset on the other 2 parachains, okay? Then what we are going to do is to do the same, but for the NFT. So we have our real-world asset NFT defined on Staymine, but we want to use that. A Staymine doesn't have any like kind of logic that would allow us to play, with that NFT. So we will need to transfer it to other parachains that will do that for us. So basically, that's what we are going to do. We are going to reserve-based transfer the NFT from Staymine to a stout parachain. Then, as a stout basically hosts this application that borrows and lending, the NFT, and gives you liquidity and so on, we are going to lock the NFT into this application. We are going to use this application on the stout parachain. Finally, the same application will basically transfer, okay, the STUSDs that we will get from the process of locking the NFT, and we are going to invest it on Trappist, okay, by using by basically adding liquidity to the DEX, okay, that we have defined on Trappist, and this will generate yields. So very quick, we are going to use the NFT. We are going to send it to a stout. We are going to borrow. We are going to lock it. We are going to get some borrowed stablecoins, and we are going to Trappist to generate some yields. But we say NFT cross-chain transfers. That's something that we cannot do that, right? I mean, if you think about it, XCM does not support NFTs transfers. So why can't we do this in this use case? The answer to that is we are using already XCM v3. Okay, and this is the part that we say that this code shouldn't be considered as a production, because basically the PR for XCM v3 is not ready, it's not merged yet, meaning it's not ready, but as it is open source, we basically just merge it into our own version of Polkadot. We created our whole ecosystem using XCM v3, and we start testing this functionality. This is why Trappist, as a project, is an internal lab. We consider that an internal lab that let us test these technologies in advance. But you can see, for transferring the NFTs, we are using already XCM v3. But let's get some action, okay? Let's just try executing stuff. So first of all, in this cross-chain, okay, mental model you need to build, in a way, you need to relate, okay, on the origin, on the destinations, how the assets are linked, all right? Because you can have different definitions of the asset, and you might correlate them. Meaning you can have the asset ID on Statemine 1, and you want it to relate it with the asset ID 9 if you want to. For sake of simplicity, we will have the same asset IDs, okay, in both parachains. But the asset registry is basically a palette that we have created to say, okay, every asset that comes from Statemine with ID 1, we will map it to an asset ID 1 living on Trappist. And we will do something similar on the Stout parachain as well. So let's basically do this. This is basically doing the call. We are saying that the asset ID 1 living on Trappist will be linked, okay, with an asset ID defining on the parachain 1000, which is Statemine, okay? Very quick. We are going to check the events. And yeah, we can see now we have the asset ID 1, which is related to this, let's say, remote, okay, asset, which is defined, or reserve-based, reserve-but asset, which is defined on Statemine, okay? Good. All right. All right. The second step that we will do is we are going to transfer the stable coins that are defined on the reserve on Statemine. So let's repeat it again. I will repeat some slides because as the use case is very long and it's complex, I will repeat some of the slides so you can refresh your mind and you can follow it. So on Statemine, remember that we have the STUSD, okay? And we need to basically transfer to the parachain, so we found the protocols that we will use. So we are going to do that, and what is going to happen on the Stout, on the Trappist, we are going to see the mint event, okay, receiving the XCM call. Also, something to, as I said before, we are going to transfer, okay, the STUSD directly to the Vault application of the NFT borrow and lending, okay? So if you think about it, the borrow and lending application, in order to borrow money, needs to first have the money, okay? So we are going to just solve that in one XCM call. Okay, this is important. And if I'm not wrong, I think right there is the person who pushed the PR for this. So basically, hello, this is, and I will mention it, this comes from the Moonbeam team, actually. So in order to pay the fees in the XCM, to pay the XCM fees with an asset, okay, like an STUSD or whatever, the asset needs to be sufficient, okay? You know, this existential deposit thing, okay? This is maybe, I will not go into details on that, but the thing is you can set, with the palette assets, you can set the asset as sufficient, and basically that will make the asset okay, to meet the existential deposit, even if you don't have the native token, okay, in your account, okay? But this is a requirement to pay the fees of the XCM call using an asset which is not a native token of the chain, all right? So let's go into start transferring. We are on a statement. We are using the limit reserve transfer extrinsic. And what we are saying here is like we are setting the destination, which is the parachain 3000, which is a stout parachain. We are going to set the beneficiary. This like long sequence of numbers and characters is the account that will work as the NFT, as the borrow and lending application vault. And then we are going to say, okay, this number that you see there, here, which is the general index one, is basically the asset ID one, okay? You can map it like that. And then we will transfer that amount of money from a statement to a stout, okay? So if we, okay, cool. On a statement, we will see here that, yeah, we have like the assets being locked on the sovereign account of the parachain. Don't worry, you just can think like the asset gets locked on a statement, and the XCM call was attempt. Then on the stout parachain, we received the event that the assets were issued, all right? So now we have STUSD available on the stout parachain. Cool. We need to do the same with Trappist, because what we are going to do after this is that we are going to basically spin up the decentralized exchange that we were talking about before. All right, so basically I will forward the video. All right, on statement we see again that the tokens are locked. And on Trappist, the event should come now. All right, we received the success, the received message success. Yeah, and then we got it. This basically means like Alice on Trappist received, you know, the asset that was sent before. All right, we will use this money to basically found a star like the DEX, right? That we will use in the use case. All right. So now we have the two parachains with the founds already, with the STUSDs, okay? All right. So what we are going to do with that money is we will get the STUSDs that we received from statement, and we will get the native token of the Trappist parachain. With that, we are going to create that exchange that then in a decentralized way, it will let us, okay, exchange like this hoop native token and STUSDs. So let's suppose that I want to buy hoops on Trappist. Now I can do it because I have like this decentralized exchange that is like offering this exchange, all right? Piece of information, this like DEX was built using the Palette DEX. And this Palette DEX is basically based on Uniswap v1 specification. Okay, it's like it's the first, very much first versions of Uniswap put into a palette. So, very simple. We get the DEX palette, then we get that the create exchange extrinsic. This will basically create the exchange. But something like I would need to explain is like in a DEX, right? When you create like a liquidity pool is called, you will receive a liquidity provider token. This is the result that when you basically provide liquidity, as a result, you get like LP token, okay? This is like if you have, I don't know, used a DEX before, this is familiar to you. But yeah, I just need to explain that. So, all right, I execute this. Sorry, something I didn't mention is like in here, this asset ID receives the ID, right, of the asset we will provide. In this case, is STUSD, right? It's the stablecoin we received from statement. And in this currency amount, what it means is like we are going to provide the hoop tokens, which is the native token of the parachain. All right, we see the events here, that the LP token was issued, the liquidity was added, and the exchange was created, okay? So now we have everything in place to start swapping hoops by STUSD and the other way around. Okay, now let's go to the funny part. We are going to transfer the NFTs from StayMine to Stout, all right? So you remember that now we got that real world asset, NFT, we wanted to send it to the Stout parachain to make use of that. And again, what is this happening is like this is doing behind the scenes is locking the NFT on StayMine and is creating a derived NFT version on Stout. Okay, this is like cross-chain reserve-based transfer works. Okay, this is for developers that have interact with the Palette Unix in order to receive NFTs. Okay, remotely, let's say. We define this foreign Unix. Okay, this is basically a very simple change that you need to do on the Palette Unix. Instead of like defining a connection ID with a primitive like U32, you point it to a multi-location. With the item ID, you use the asset instance of XCM. I will not go into details of what these are because it's heavy. And then the create origin basically is restricting that the only origin allowed to create this asset or these NFTs are XCM origins, all right? Very like specific in terms of substrate and XCM. And this is, one example of this foreign creators code that you might use to restrict the origins. Okay, so we are going to execute that. We can see that we have the asset. Okay, we have, sorry, the NFT on StayMine. We see it like we have the collection ID 1 and the asset ID 77. And first of all, this is important. What you need to do is you need to create a collection on the destination before it's able to receive, okay, the NFT. So I'm just for sake of simplicity, I'm like forcing the create with sudo on the Stout parachain. This will basically create the collection. And now let's go into transfer the NFT, all right? So it's very similar to the way we did it before. We use the same extrinsic, the limited reserve transfer. I need to use a fungible token to pay the fees, right? We will use STUSDs to pay that XCM fee. And this is where the magic comes, all right? We are going to basically transfer not fungible type, and you will see that this index 77 is the ID, okay, of the NFT. So, yeah, we use this, and we execute it. All right, I will forward the video. So you can see here that there is a manipulation internally with how the unit asset is basically handled, and we see like the XCM message was sent, and this is important. On the Stout parachain, we received the event that the foreign unit was created. All right, and if you see the collection is pointing to a remote collection, okay, to a foreign collection, and you can see here that it's pointing to parachain 1000 with general index 1, and the index 77 is the ID of the NFT that was created on StayMine, right? Again, this is sending from StayMine to a Stout parachain, and this is the event that on Stout parachain is receiving the NFT. Good. So now we have the NFT on Stout. Good. Okay, this is like proving like the NFT really exists on the Stout parachain. I'm not scamming, all right? I'm not lying. Cool, it's there. All right, we got the NFT on Trappist, and now, on Stout. And now what, right? I want to make use of that NFT so I can get liquidity and I can invest it, and make some bucks of it. So we are going to deposit the NFT on this borrow and lending application that we have developed, and we are going to receive the STUSDs. But not only that, this application, this palette we built, is going to automatically transfer the STUSDs, the borrowed STUSDs from the application into Trappist, right? Everything in one call. We create the palette. I don't have enough time to, show the structure of the palette. If you're interested, we can, after the presentation, we can review the code, every code together that you wanted to. Okay, video appears. So, good. We have this deposit NFT and transfer liquidity, that is called. Basically, this received the NFT on the stout. But if you think, if you see it here, okay, this is for locating the NFT on stout parachain. Is pointing to the reserve, right? Because this is a foreign unique. So we will basically provide what is called in XCM multi-location, all right? And just for sake of simplicity, I will just set the amount that the protocol will borrow, all right? So there is no like a very much advanced use case that will value the NFT. I mean, that's for you developers to define how to want to price the NFT or to set a value on the NFT. We will call this, and what I expect is to have the NFT locked and to automatically send the borrow STUSD to Trappist. Remember, on Trappist, we have the DeFi service, okay? It's where we can invest the money and the token, let's say. And yeah, right here, the first event we can see is like the foreign unique was transferred, and now is like locked into the vault of the real world asset borrow and lending application. So you don't owe the NFT anymore, right? So in order to get the liquidity, you have to lock the NFT, all right? So you don't have access to that NFT anymore. If you want to have access to that NFT anymore, you basically need to claim it, okay? That's for the next presentation. And now we can see here that as the result of locking the NFT, there were some STUSDs transferred to Trappist. So what we might expect is on Trappist have some STUSDs mint on the Bob account. And I hope that happens. It's a video, of course, should happen. Nice, cool. We have on Bob. I'm speaking very, confident because it's a video. Otherwise, I don't know if I would be so brave, to be honest. All right. Okay, so we have the STUSDs transfer from Stout to Trappist because of this cross-chain application that we have developed, all right? Now what we will do is remotely, we are going to say from Stout that we want to invest that tokens that we have borrowed, well, we have received, okay? And remotely, we are going to swap SUSDs to Hoop, which is the native token of the parachain, and we are going to provide liquidity. And this is what's going to generate yield for this whole cross-chain transfer that happened. How do we do that? Okay, in XCM terms, we use an instructions called XCM transact. Okay, these instructions let us execute remote calls from one parachain to another. And that's what we are going to do. From a Stout, we are going to use the XCM, we are going to send an XCM transact. We will do basically all the right part, into Trappist, okay? All right, this is a little bit specific, but there is there is a challenge right now if you want to do this. In order to send remote calls, you need to know the encoded, right? The scale encoded from the pallets and the stringics. So it's not like, oh, okay, yeah, I just get my transact instruction and I execute it on the destination and yeah, I mean, I get millionaire. No, it's not, it doesn't work like that. What basically you need to do is you need to map, okay, the indexes and the numbers you have assigned to the pallets and to the extrinsics. And yeah, it's not like a very simple process, it's very manual. So for example, if on the destination I change anything on these numbers, I break the whole application. So there are already discussions about how we can solve this as an ecosystem. So for example, Just information, there is a proposal to pick something called XCM dialects, which is like a tool that will let us, with all the parachains, to have like a common dialect for executing these transacts, all right? Okay, very specific about code that we can review after on it or any different session. And now what we are going to do is we are going to call this add remote liquidity that with what it will basically do is do this XCM transact, which will like make all these remote calls that will add liquidity and will swap and everything that we discussed before. So this is saying from the start parachain, I will execute the transact. So you can see here that the first event is like the fees were paid, and the XCM XCMP message was sent, and now I added like a custom event on this palette that says like the add remote liquidity attempt. And why do I use the word attempt? Okay, because sending an XCM message from the origin doesn't mean that the message will be executed on the destination. All right, I mean we send the message, but it's on the destination to interpret this message and execute it. So if I go now on Trappist, I basically see like, okay, let me go, let me wait. All right, good. So I see like Bob received some liquid provided, some LP token was minted into Bob account. That some liquidity was added, okay, from the Bob funds. And the batch was completed. Okay, so this is the end of the whole use case, all right? Maybe you might, I don't know if you follow all the steps, but just to do a recap, we got like some stable coins we were defined on the reserve chain. We used those stable coins to found two different applications, complete different applications. Also, we got the NFT on the reserve chain, which is on Staymine. We send it to Stout. We lock it there. We receive some money because of that, and then we transfer it into another parachain to invest it. So, as a recap, what I wanted to show here is like we can build the next generation, okay, of cross-chain applications with Polkadot, with XCM, with parachains, and all this stuff. So right now, we are going to close the presentations. We are going to take some takeaways, key takeaways, and I will leave Steve to present those.
Yes. So, yeah. Thank you, Hector. And I hope you enjoyed this showcase. Takeaways, obviously, XCM is amazing. I think Hector showed you how you can build like the future of cross-chain application and services, combining different features from different parachains. We've kind of showed you a glimpse of what's coming with XCM v3 and transfers of NFTs across chain. And then Trappist is our little lab, so feel free to talk to us, to contribute some ideas. We are always looking for good stuff to build in there. And we'll see you at the next presentation at the next conference. Yeah. If you are interested to check out the code, it's all there.